Hi everyone, so in this video I would like to share some good news and some bad news about the battery management system which I've been working on. So the good news is it's going to be possible to make and it's likely going to work. The bad news is I cannot sell completed boards because all the certifications to basically market and sell this legally is going to cost over £10,000 for EMC testing, automotive certification testing, I think CE related stuff as well, or UK CA, I think. There's lots of certifications which this will actually need to be sold legally based on my research. So there's actually, it's confusing me because there's actually boards on eBay just now, battery management system boards, buck converters and all the rest of it, which do not seem to have any certifications yet. They can still be sold. And there's things like the Open Inverter project, where there's inverter drop-in boards for electric cars and little battery management systems as well, and they don't appear to have any sort of legal disclaimer on them, even from what I could see, or even anything to do with certifications. So maybe there is a way that I can actually make these and sell them, but from the research I've done, I just don't think there is, unless I win the lottery or I find an investor. But an investor is not something which I really want because that puts pressure on me where I have to perform, this has to work, it has to make money, or else I've got an angry investor, and I don't want an angry investor basically. So that option is really just a no-go. So that just leaves me with the only option to being to just sell basically empty boards, and the user will have to just download the bill of materials and order all the parts and solder them themselves. So that would be basically a blank circuit board and the solder mask stencil, and users would be on their own in that respect, which kind of defeats my purpose of making this a computer free product, and the option to be used without any apps or computers. If users are building these themselves, then they need to flash the firmware onto the chip, which is actually fairly easy to do, but it kind of defeats the computer free vision which I had for this. But say I could sell these as completed units, then obviously the user would just be able to take them, set some solder jumpers on the bottom of the board, and then install it in their system, and then it would just work. But it also has CAN bus interfaces as well for full configuration of all operating parameters in great detail. So it would come with a companion app which would sort of like, it'd be like the VESC tool but slightly different. It would have no dependencies, it would run on Windows XP all the way through to the current version of Windows. It would be very lightweight, very simple compared to the VESC tool. So regarding the VESC tool, I'm actually going to do something similar hopefully, and this is it here. This would be my sort of brand name. The boards which I make up will have this on it, so I would be the only one who'd be using this brand name. It's not like other people could then go and just make up boards and stick this on it, and basically just copy this name. Only the boards which I sell and supply could actually have this on it, and other people would just have to say compatible with Zentron systems, probably something like that, something to that effect. So there's nothing much on here really at the moment. We've just got a detailed description of what I plan for this thing to be able to do. So you've just got a huge list of features really, and a sort of basic principle of operation description. And much of these parameters will be set by solder jumpers on the other side of the board. Another thing which is going to be quite cool about it is it's going to be covered in LEDs, so when it's balancing you'll see all the little LEDs flashing. There'll be a strip of LEDs here which indicate various system parameters as well. There'll be all the state flag outputs. In fact, the system connector has actually got more pins on it than the battery harness connector, which just goes to show how flexible this thing is going to be. It will work from 6 to 16 cells as well, so it covers most applications you'd want to use this in. If you want to put it in a solar power system, you could, nothing's stopping you. If you want to put it in a car, you could at your own risk after you've built it up yourself, unless I somehow get enough money to put this thing through EMC testing, automotive certification and all the rest of it. But I'm not going to be winning the lottery, so do not count on that. Unless, of course, there's some other loophole I can use. If there is, if you could let me know, that would be absolutely brilliant. But yeah, this is CPM4 from Zentron Systems, and it's the fourth iteration of battery management systems I've been developing. The previous versions were totally analog electronics based, and while they would be very reliable, there's no way to really safely use them in an enclosed system like this where you cannot regularly check up on your battery using a multimeter, because if something failed on the analog board, you would not know about it until your battery is going on fire, at which point it's too late. So this system is going to have tons of safety features on it because it's actually using a proper BMS integrated circuit. So all safety features will be there. It's going to have the option for a pyrofuse output, where you would send that to a pyrofuse controller to blow a pyrofuse in an emergency. Crash input, high voltage interlock, drives contactors from this board, and you just buy as many of these as you need for your pack. For a 96 cell pack you will need 6 of these, I believe. But yeah, the project's well on track anyway. I reckon I'm going to be able to create something here which works, but as for the certification and stuff, that's just not happening, unfortunately.